All right, so our next example is looking a little more challenging, right? Again, we're looking for solutions on the interval 0 to 2 pi. And this one, we don't see any factors that are common to every single term, so we don't have anything we can factor out. However, this time we are going to try using some of our double angle formulas. Okay, so we know sine 2x, let's go back to red, we can write that one 2 sine x cosine x, and we got times the other sine x, so we'll leave that there. All right, minus. Now here, we've got a couple of options, right? We might do a sine squared, cosine squared minus sine squared. Or we might do the 2 cosine squared minus 1 or the 1 minus 2 sine squared. Now, I'm going to make an educated guess here because there's all cosine terms in this one and all cosine terms in this one. And we see that we're going to have a sine squared here. We could get rid of the sines if we wanted to. So I'm going to use, for the cosine 2x, the 2 cosine squared x minus 1 double angled identity for cosine 2x. Now, if you ended up using one of the others, you would eventually be able to get this equation all in terms of sine or all in terms of cosine. Or a product there of, just something with just sines and something with just cosines. But I think this is going to be a little bit shorter, still not short though. Okay, so we've got 2 sine squared cosine minus, let's see what we got here. I think we're going to leave it for now. 2 cosine squared x minus 1 times cosine equals negative cosine. Okay. Now this sine squared, we know we can get rid of that. We can get rid of sine, convert it to cosine, right? So Pythagorean theorem. So these were double angles, identities, 2 of them. And now we're going to use Pythagorean theorem, Pythagorean identity. And we're going to use sine squared, so cosine squared plus sine squared equals 1. So sine squared will be 1 minus cosine squared. All right. Okay. So here's what I'm going to do, though. So we actually you'd be tempted here to divide by cosine. Okay. But if we do that, if you're not careful about it, you're going to lose a solution. You're going to lose a solution for when cosine of x is equal to 0. So what I'm going to do is I'm going to pull this negative cosine term that I forgot to write x on over to the other side, and then every single term on the left-hand side is going to have a cosine, and I'm going to factor it out. Okay? So we're going to have 2, 1 minus cosine squared times cosine minus 2 cosine squared minus 1 times cosine plus cosine equals 0. And like I said, every one of these, we've got a cosine term as part of each product here. So we're going to go ahead and pull it out. Okay. And now I'm going to go ahead and do some multiplying, right? So I've got 2 times 1 minus 2 cosine squared. Great. I've got another minus 2 cosine squared minus negative 1, so that's plus 1. And then I factor out this cosine here, so that's going to be a 1 also, so plus another 1. Okay, so we need to combine some terms here. Great. Oops, darn it. Okay, got too close to the bottom. All right, so we've got 2 plus 1 plus 1, that's 4. We've got minus 2 cosine, both squared, minus 4 cosine squared x equals 0. So at this point now, we can split this. This one's pretty tough, okay? It's pretty tough. It'll take you a long time until you've practiced over and over again, every time. So, all right, what do we got here? Cosine x equals 0, right? Because that's one factor in our product here. And we know from that, of course, where is cosine equal to 0? So that's going to be x is what? Pi over 2, 90 degrees, 3 pi over 2. Anything else in that interval? No. Okay, so what do we have for the rest of it? For this one, 4 minus 4 cosine squared equals 0. So 4 equals 4 cosine squared. So 1 divided by this by 4, right? Cosine squared x equals 1. So here we're going to have, remember, we're going to take square root of both sides, plus or minus, right? So cosine x is going to be plus or minus 1. Where does that happen? That happens at 0. Cosine of 0 is equal to 1. And at pi, cosine of pi is equal to -1. All that work for 3 very basic answers, right? Okay, but that's it. Except, maybe we should check this one on GeoGebra. Make sure we found all of our answers. All right, let's turn these guys off. Oops. Cancel. Stop. I guess I'm going to have to reload this page. Hold on. All right, I got that fixed. Okay, so we're going to put in y equals sine 2x times sine x minus cosine of 2x times cosine of x. That was our left-hand side, and our right-hand side we had negative cosine of x. And the question, of course, is on the interval 0 to 2 pi, how many intersections do we have and where are they, right? So 0 to 2 pi, how many intersections do they have? Can I use the intersect tool here? And it's going to find it one at a time. But I think you can see that they're intersecting at 0, at x equals 0. The next intersection is going to happen at x equals pi over 2. Intersection at pi. Intersection at 3 pi over 2. And that's all 4. Let's see, 1, 2, 3, 4. Yep. And if we were going till 2 pi, that would be another answer. But we're not, so that's it. All right, that one's it for this one.